Okay, so I want to talk about composite functions or compositions of functions. I claim we already did a couple of these, right?
Yep.
Like this is anything you do in steps,
Okay.
right? So I just want to get some practice like going forward in steps and pulling things apart into their steps. So my first kind of idea here is just going to be there's some function, right?
Mm-hmm.
I'm going to call this first function maybe g for kicks, right? And then there's some other function that's going to happen. And I'm going to do f to the,
G of X or
yeah, you're going to do f to the output of g.
yeah.
You guys see that?
So the output of G is the input of F.
Exactly. So that means that the, okay, so this blob is clearly the,
Original input.
yeah, that's kind of the original inputs, right? That's the domain of g. Good with that? Okay, what's the output of g? What's that blob?
The range of
That's going to be the range of g, right?
And the domain of it.
yes.
Yeah, and at least some of it has to fit into f.
Yeah.
You guys see that?
Mm-hmm.
Okay, these things don't have to actually be the same.
Okay.
You guys see that? Like, there's no guarantee that they're the same at least.
Like you can get a range out and you can just chop that section of that out and put it as the input for F.
Yeah, for instance, if I tried to do, like, let me give you a funny example. If I tried to do, say, h of x is the square root of sine of x.
Okay.
Maybe easier example without trig.
Well, that's
That's fine.
How about this?
Okay.
So, which kind of things can you fit into the square root function?
Positive numbers and 0. Oh.
Right? So you're,
Oh yeah.
the square root takes positive things and 0, right? So it takes the closed interval from 0 to infinity
Yes.
Except negative.
and takes that somewhere.
Mm-hmm.
I don't really care where. You guys see that?
Yeah.
There's also in here, what's the other function here?
Subtraction of 1.
Subtraction by 1, right? So the idea of subtracting 1, what's the domain for that?
everything.
Yeah.
All wheels. Blended together.
Maybe if I wrote this as x minus 1, would that be? Or
Yeah. Makes it.
take some stuff and subtract 1?
Yeah, I think it's the squiggly underneath the square root too. You might as well keep your notation the same.
Okay. So this takes the real numbers and takes them where?
I don't care.
Down one.
Yeah, kind of down 1, right?
Yeah.
It takes them to the real numbers again,
Oh, yeah.
right? But if I'm going to do h, right? What's the first step in h?
To make sure that it's not negative.
No, I mean just like if I give you an x, what's the first thing you
Oh,
do to it?
subtract
Do you
one.
take the square root or do you subtract 1?
We subtract 1.
You all subtract 1?
Yeah.
Okay, so I'm applying the stuff minus 1 function first, right? So this would be all of r here, right?
Mm-hmm.
What's this guy?
All of mine.
All of r. And then what am I trying to do?
Make sure you're going to square root it.
Yeah, I'm trying to square root that stuff, right?
Yeah.
Does the square root know what to do with all of that?
Not all of it. Just the part.
Not all of it, but some of it,
Yeah.
right?
Right.
You guys see that?
Yeah, that's fair.
So that's why I'm not going to write equals the domain of f here,
Makes sense.
right? Because it's not necessarily all of the domain of f. It might be too big or too small. Right? What I'm going to do instead is I'm going to write think the domain of f. You guys see that?
Yep.
And then what's this guy going to be?
Range of.
Range of.
Yeah, except it might not be all of it. The reason it might not be all of it
That's because it's not all the domain.
is that this didn't necessarily have to be all the domain of f.
Okay.
You guys see that?
Yes.
Okay, so if I want to figure out what the domain is for a composite function, in other words, maybe here, right? How do I figure that out? Like, what is the process I go through to be like, what's the domain of the composite? So what's H's domain here?
Oh,
Is it all real numbers? Because I can fit all real numbers into the x minus 1 part.
no, you need to consider the square root side too.
Yeah, I need to be able to do the square root to the result of that, right?
So you need to make sure it's all real except.
You guys see that?
So like 1 up.
So I want to know which things are going to make this part under the square root positive or at least 0.
1.
You guys see that? So that's me thinking, okay, I need x minus 1 to be bigger than or equal to 0.
Right.
And when does that happen?
A 1 above.
At 1 and above. This is an easy inequality to solve, right?
Yeah.
It's possible that it might be best to graph whatever you get here
Okay.
to try to find multiple spots or something. In this case, it's pretty easy. It's just x is bigger than or equal to 1, right? And so if I was doing a good job with my composite function, instead of having this be r, right? Like this can't be the maximum this thing can take. It's just this part of r up here. So x is bigger than 1, 1
Okay.
that actually get to the end. You guys see that?
Yep.
Questions, like?
What happens when the domain of f doesn't include any of the range of g? Like the
Oh, what happens if they just straight up don't overlap?
Yeah.
That's a great question. Let's have an example. I bet we can make one like that. So what I would like is for these to not be the same at all,
Yeah.
right?
If
You
you
guys
have
see
a
that?
function going from the first blob to the last blob of that,
Oh,
is the domain of that the range of the first function g?
is the domain of
Or I
that?
should say, is the domain of the whole thing equal to the domain of the last blob?
Not necessarily.
Not necessarily.
It could be, but yeah, in practice, not. So let me make an example of this kind of pathological thing first, and then I'll name some stuff because I didn't even tell you what to actually name that function. You guys see that? Like I just told you you can do this, but I didn't give you a naming convention. So let's have a horrible example. Let's see. So I want something where, well, I want to make this picture happen.
Right.
Right? I want a first function that goes somewhere, and then a second function that can't take any of those outputs. Like, so I really do want these blobs to be like totally separated. So let's see if we can make something like that.
The square root of negative the absolute value of x.
Dude, nice. So if you make your second function the square root, right? Then this blob has to be numbers that are bigger than 0 up to positive infinity, right? So now I need to find a function that outputs things that are definitely not positive.
Negative absolute value.
Like negative the absolute value of x, right? Or negative the absolute value of stuff, maybe. To be totally consistent with my notation. Okay. Except not quite right.
Except 0.
Because these kiss at a point.
0.
You guys see that? So these two blobs have one just very small overlapping point, which is 0.
Unless we put it in the bottom, make it a fraction, right? 1 over. Perfect.
Sure, that'll work. And now they definitely don't kiss at 0.
Wow, 1 over the negative absolute value of stuff.
You guys see that?
The square root of 1 over the negative
Cool.
That's
So this would be a composite function. Oh, and let me give you the naming convention while we're here. I'm going to call this one, I don't know, a of x for like, it's like the absolute value. And I'm going to call this one,
B of X.
sure. Because it's the second function.
Right.
Okay, now if I want to write the composite, I know how to write a formula for the composite function. What's the formula for the composite function?
A, B, X.
No, not that thing.
The square root of 1 over.
Could be
negative
square
X.
root of
1 over negative.
1 over negative absolute value of x, right?
Cool.
Now, what is the name of this function?
G of X. A, B of X. A, B, X squared.
A, b of x. You're thinking like this, right? A, b of x.
No, that wasn't what I was thinking.
Oh, this is what you should be thinking.
No.
How about this? Is that right? Which thing are you doing first in there? Like if you feed an x in that,
You do B of X first.
you do the thing in the parentheses first, right? So you're going to do b first. Is that what I have in my picture?
No, actually.
No, because that one might actually work, right? In fact, that one does actually work. You guys see that? So the order matters here, right? Because if you do these in the other order, they work just fine. Well, they don't work just fine for being an example of something that doesn't work. Yeah, good call. So this is not a of b of x. This thing is
B of X times A.
b of a of x.
Yeah.
And I'm going to pick on Zach. It's not multiplication.
Okay.
You guys see that?
A of X.
It is definitively not multiplication. It is the function wrappers that are in the order they're being done.
Okay.
You guys see that? So do not do crazy things like dividing.
I'm a function wrapper.
You guys see that?
Yeah.
Okay. Let me make another big example here, and then we can